Today we're going to be talking about bone growth and development, and we're beginning with endochondral ossification. Endochondral ossification is one of two essential processes for the development of the skeleton. Ossification means bone formation, and this affects the formation of all bones except the intermembranous bones, or irregular bones, which we'll be getting to later. Endochondral ossification is the process of replacing cartilage with bone. While the fetus is still in the womb, the embryonic skeleton is made mostly of hyaline cartilage. This cartilage model is showing how bone should look once the bone is completely formed. Ossification starts when chondrocytes begin to swell and die, and the periosteum forms along the outside, and allows osteoblasts, which are bone-forming cells, blood vessels, and nerve cells inside to start creating bone. This starts at the primary ossification center, where death begins at the middle of the diaphysis. Then it moves to the secondary ossification centers, where the next round of death begins at the epiphyses. These ossification centers never converge, which leaves spaces of cartilage between the diaphysis and both of the epiphyses at both of the epiphyses, where cartilage is replaced by spongy bone. The periosteum still produces osteoblasts, which build up outside the spongy bone and eventually forms compact bone. However, the spongy bone remains in the epiphyseal discs. Once the fetus has been born, post-embryonic development begins. Cartilage that is still present in the epiphyseal discs is continuously dividing, meaning that as cartilage ages, it begins to be replaced by bone, whereas new cartilage is formed and the process continues. This stops after puberty because once the epiphyseal cartilage turns into bone, the growth stops, and most people are done growing after they've finished puberty.